Alright guys, so today we're going to be discussing the myth whether higher temperatures actually cause higher reactions. In the myth, one of the students does it at 50, and then she was warned that if she does it more than 50, it would not work. However, one of the other students said that she did it at 65, and it did work. So today we're going to be seeing if higher temperatures actually cause higher reactions, and we're also going to see how high we can go to see if the reaction actually happens or if it stops happening at some point. Alright guys, my prediction for this experiment is that I think the higher temperature, the more reaction there will be. However, at some point the enzymes found in the yeast will probably denature, and therefore the reaction will not happen. Kinetic energy will still increase, but to a certain degree only. But yeah, we'll see what happens.
Alright, I'm gonna agree with David and say that as temperature increases, the reaction will also increase, but there will be a certain point at which it will stop working. So we're gonna see.
I predict that with increasing temperature, the rate of reaction is gonna go up. Okay, so the science behind the reaction is that as the temperature goes up, the collision increases as there is increase in kinetic energy. Basically, reactants get to react more if there is a high temperature due to more collision. And here we have yeast as a positive catalyst. Yeast contains an enzyme called catalase or whatever is that, I don't know how to pronounce it, which basically helps hydrogen peroxide break down into water and oxygen gas. And yeast is acting as a positive catalyst, as the catalyst helps to break down the hydrogen peroxide, providing an alternative path to a reaction which has got lower activation energy. That's why the rate of that's how yeast is increasing the rate of reaction. So another science is that yeast is a living being, and this is acting as our catalyst. So in order for yeast to work as a catalyst, we should not be going over temperature where the yeast could not survive. I mean, yeast pretty much can survive in the temperature where a human can survive.
One more reason for why we cannot go that high is also due to the enzymes found in the yeast. Enzymes are the catalyst of a reaction, and therefore, if the enzymes die or denature, as scientists say it, if the enzymes denature, there will be no reaction. Therefore, you will not see the elephant toothpaste. So that's why we also need to take care of the temperature in that sense. Yeast mixed with some warm water right here. Is that all? And we're gonna stir it up for a little bit, and then we're gonna be adding it.
Excellent stirring.
Yes.
Here's our hydrogen peroxide. We're going green this time.
Stirring here. Well, it's just stirring, bro. You know. But it looks like wet dirt. You know.
Indeed.
All right, let's go for it then. So we have to convert tablespoons and teaspoons into milliliters because we don't have tablespoons and teaspoons, and so we needed 1 teaspoon of dry yeast, active dry yeast, and so that was 15 milliliters. And then for the water, we needed 2 tablespoons of water, and I got 30 ml, which I have already poured into here. So we mix those, and then we add them to the hydrogen peroxide solution that we have there, and then the reaction should happen. Trial number 1, room temperature here, room temperature as well. Let's see how the reaction works. Room temperature currently is about 20 Celsius, so it's not too cold, not too hot. Let's try it.
What do we think?
That's cool. Looks like a volcano, Loki.
Very cool.
Let's go, success. I think the higher temperature we go, the maybe not the more, but the faster the reaction will happen. We'll see. Yeah. So Professor Harrison just scolded me because I wasn't wearing my goggles. So now I'm gonna put them on. They're not coming off my eyes for the whole experiment today, yeah? Great.
Should there be something up there?
This is fine.
Is that water?
Yes, water.
Okay. I was like, that's not the peroxide, is it?
It burns. As you guys can see, Dr. Harrison made this Bunsen burner work for us. Thank you, Dr. Harrison. Alright, yes, great. 20 degrees warmer than last time. Let's see what happens. Okay, this looks clear enough to you guys? It does, right? Perfect. Alright. Are you ready? Okay. See, very similar to last one. You guys see a difference?
Maybe more foam. Yeah. Pretty solid reaction. We'll see how it lines up time-wise.
Yeah, I'm pretty sure it was the same, but this one seems to have more foam than last one. Well, let's see. We're gonna watch this up.
Ready.
This is trial number 3. We're gonna do it at 60 degrees now. We warmed up the water to 60 degrees Celsius, and I'm stirring it up. Honestly, it seems to be a bit smoother, so I think this is gonna make a change. But let's see though. Okay. It's a reaction. There. Okay, guys. Oh,
Which is like fun.
Pretty good reaction
that
there.
was pretty quick as well. Yeah, I think it made a difference, but we'll check in the video to see if it actually did.
Or just start heating up the water. And then as soon as we take it off, pour it in. Oh, and dish soap. Okay. Using the dish soap, then we'll just have a dish soap. Yeah, that we can do that.
Alright guys, unfortunately we're out of yeast, so our last 2 trials we're gonna do with 80 degrees Celsius and then 100 degrees Celsius. Unfortunately we won't be able to do it. We only did 20, which was room temperature. We did 40 then to replicate what the myth was saying, and then the 61 probably worked the best, so I actually had high expectations for the 81 and the 101. Unfortunately though, it will not be able to happen, so alright guys, so after our 3 trials, we were planning to do 5 actually, but after the 3 trials, we did end up doing it at 60 degrees. We're planning to do 80 and 100 as well, but we couldn't do it, that's okay. The one at 60 did work, and it worked pretty well, I would say better than even the one at 40 and the one at 20, so therefore, I think this myth is busted. The myth said how over 50 degrees wouldn't work, but it did work, and so the myth is busted. I think the higher you go, probably, the higher reaction you will get, until a certain point, until the enzymes in nature, which is usually around 100 degrees, I think. So yeah, myth is busted, guys. We'll see you in the next one.